Our purpose for doing this session was to make sure that what was discussed in the poster sessions gets into our record. So we have our note takers / writers here. They, of course, participated in the poster session. These are qualified lunar scientists here, and so they're asking the good questions and all. And so what we want to do is make sure that this, you know, anything that you have, the poster presenters have, that you want to make sure gets into the record, please come up and talk about it. So it's kind of up to you. We'll go as long, no more than 20 minutes, but as long as we have folks up at the microphone.
Yeah,
so
just one clarification to that. This is not another presentation, but it's sort of related to what has gone on in the talks. Your posters are related to the objectives of this workshop, so we want to make sure we capture the comments and the linkages between the posters and the presentations. And we got nothing. Right. Next.
All right, just because nobody else is. We were just talking, and we've had a wonderful set of proposed locations for landing. Must be dozens of them. I think it could be very helpful to capture all of them in a database, listing a whole bunch of things like exactly where they are, how big a region you need to look at, or how small a region, and then what science you're trying to achieve, and what disturbance to that region would, this is the policy part, would prevent that science being done. So if somebody else lands and blows away the surface in the region of the swirls that you cared about most, does that destroy the science? I mean, that probably, I'm ignorant, so that's probably a poor example. But I think a database like that would start to get us thinking very concretely about these issues, which is very hard to do when it's just in principle, if you disturb this or that. Well, yep. Let's try and make it concrete.
Okay. Thank you, Martin.
Thank you.
Yeah. Tony?
Yeah, hi. I wanted to connect the presentation I gave for some of the site selection to Mark Shirley's poster that he gave on traverse planning. And I bring this up because while we saw a number of very interesting sites, I think there are some unrealistic expectations of what rovers can actually do, especially rovers that are under $1.5 billion, perhaps. You know, the speeds made good is what we refer to, and it's a nautical term for the average speed, because there's decision time. Once you land on the surface, there's never a straight line. While it's flat, and that's another thing, we talk about slopes. Slopes on the scale of the rover are what matters, not slopes at the scale of Lola 200-meter DEM. So we have to be a little careful and dig deep into each of these sites and really get realistic expectations of what you could do in a lunar day and 4 lunar days, et cetera, et cetera, et cetera, because I think that it's just a realization that I've personally had over the last 3 years of digging so deep into this that our average speed is only 0.5 centimeter per second. You know, and that's been proven out. The lunicods were about 0.5 centimeter and 1.5 centimeters per second. And quote unquote real-time traversing doesn't exist, right? It's not just the speed of light, but if you're working with DSN, they won't promise you delays less than 10 seconds because there's latency in the system, and then there's decision time. And then you stop to do science. You're never actually just driving continuously. And a lot of the plans that we've done, hopefully you went by and saw Mark's tool, there's usually about 25%, 35% of the time, you're sitting still doing science. You're not driving. If it's solar powered, you're sitting still perhaps charging your batteries for another 25% of the time. So we need to be a little more realistic, I think, in what we can actually accomplish with rover missions.
I have a question for you, Tony, before you run away.
Yeah.
So the implication I get from your comment is that the Lola data are not adequate.
I think you just need to be careful. You know, that when you look at a site and you say it's smooth and rock free, a 1 meter rover doesn't care about a 1 meter boulder, which is what we see in a lot of the LRO data. Like what they care about is a rock typically half the diameter of the wheel, which is 25 centimeters for a 50 centimeter wheel, which is a big wheel. And so likewise slopes, lots of little fresh craters. The interior walls of those craters, the slopes are 25 to 35 degrees. And with smaller wheels, it's not so much the slope that matters, it's the slip. And the wheel embeds, and then embeds more as you try to get out. And this has been shown again and again in soft materials. So there's a lot of issues there that need to be considered. It's a detail.
Yeah. Tony, I have a question for you. So I had a demo of the Traverse Planning tool. It is just absolutely fantastic. You know, it uses autonomous, it says that it's on.
Yeah.
Can
There you go. Yeah.
Oh, get closer? Okay, all right.
I was just calling Mike. Mike's over here.
So what was I going to say?
What were you saying?
Yeah. So anyway, the Traverse Planning tool is just fantastic, bottom line. I mean, it uses some really great things in autonomy that I know you're working with the autonomy team here at Ames on. And what I wanted to know is this generalizable to other kinds of traverses besides what you're planning to from RP? I presume the answer is yes. And then if so, is this a tool that we could put in a technology section that we will be developing for this report?
Well, certainly the first part I can say yes, and Mark Shirley should comment more. He's one of the primary developer. It works on map layers, but also has a number of specific engineering aspects to it that are specific to that rover system, for example. And so that needs to be considered. So there are all kinds of constraints, rules that come into it, not just the data map layers. Mark, do you want to say anything about its applicability beyond RP?
I think you answered that well. I think the software itself.
Use the microphone,
Yeah.
please, Mark.
Yeah, making you stand up. Sorry.
Yep.
Just really quickly, I think the software itself would not be that valuable, but I think we could share ideas. The tool really is a bundle of a few general algorithms, which would be easy for somebody
Reproduce,
to
yeah.
implement, and a lot of specific tools that are very customized to our rover and our mission constraints.
Okay.
So the best thing would be just to share ideas on traverse planning.
Yeah. Maybe let me propose that we address that at the Exploration Science Forum this summer, because a lot of the community comes there, and there's no time to do it at LPSC. So thank you.
Yeah, that'd be good.
That's great.
And just I want to follow up on a point Tony, I think, was making, and we talk about the LOLA data. It's real important. You know, LOLA is, as we speak, collecting data. And if there are things that you need, now, maybe it's a spot we can't reach because we're not passing directly over 90 degrees, but don't feel hesitant to talk to the people who are collecting more data if you need more data. So if something is inadequate, Tony, let us know, and we can, you know, the LOLA team has a lot on their plate already, but happy to give them more work if they, you know, the products get updated, but maybe there's data in the last 6 months that would, if there's something you need that we can collect, don't keep it to yourself, because the last thing we want to have happen is that, well, boy, we really could have done this if we only had this data, and he's, oh, well, we have it. You just got to ask.
Yeah, we have an asset in orbit that is collecting excellent data. Let's use it if we need, if there's something that's missing.
I mean, does low angle, I mean, every image of the South Pole is low sun illumination, but does that data help characterize the boulder populations? You just need to have a little bit of topographic expression of something sticking out of the surface. It'll cast a long shadow, even if it's less than 50 centimeters. Does that help you at all?
Yes, absolutely.
Good,
We
all right.
use it.
Good, keep using it.
We will. The problem with Lola is it's
Use the microphone, Rick.
The problem, the
bald spot.
The bald spot
Whoa, whoa,
is
whoa,
an
whoa,
orbital.
whoa,
Nothing personal. No,
Lola,
because
not
I've got
Noah.
one, too.
Yeah.
But the problem is
solar
with
panel
the.
never mind.
Are you going to let me talk?
No.
Okay.
Go ahead.
Shame on you. I gave you money. I even gave you a tip.
Take it outside or say your question.
You're saying?
No, if, in the polar regions, you're currently flying over a limited altitude or latitude range, and so the very circumpolar stuff is not being covered by LOLA as well, correct?
Mm-hmm.
So but those are the places where we're doing our planning. And so the gridded products that you see from LOLA are kind of static above a certain latitude, just simply because there's no data being added there. So I don't know what you can do about that.
Well, I think it's also going beyond the gridded data and looking at each individual shot. I mean, there is the density of coverage is amazing. Let's just come out to Goddard. We'll put on a good show for you. Sit down with the LOLA guys.
Yeah, and just that,
no, we don't.
and just that, I wasn't trying to disparage the data. None of this is possible without what we have. I just want to make that clear. And really, I think it's just a cautionary comment about you really need to dig into it. And one thing we've been able to do, and you've seen this again and again, is the power of combining the various data products, LOLA with Diviner, with NAC, stereo, photoclinometry. Once you start pulling that all together, it's getting a much more complete picture at the scales I think that all these rover ideas and landed ideas need. So I think the data's there.
Yeah.
You know, the kind of, when you talk to a rover engineer, they want to know the centimeter-sized rocks. You know, of course, we're not going to get that, right? But
Well, you'll get something from Diviner, though, although not at the poles, maybe.
exactly, you'll get statistics, which is good. So I'm not trying to disparage it at all.
Well, that's okay.
Very good.
But the other thing also is to not forget Shadow Cam as well, and what Shadow Cam will be able to offer. Let's not forget if and when that happens.
Okay.
Great.
I have a question for there were several posters from the commercial providers. Is there anything from those posters that that you would like us to take away in a snapshot?
So I guess this is more less lunar science and more lunar philosophical, but we had some pretty interesting talks about planetary protection, and it's that, like, environmental impact statements are required. Environmental management, sorry. But like building on NASA aims would require an environmental impact statement, but do rovers going to the moon necessarily have the same? And then ownership was another thing. So as commercialization occurs, like 40 acres and a mule type concept where you need ownerships for corporations on the moon, perhaps.
People with bigger brains than mine are going to have to deal with that one.
Yeah.
So along those lines, I guess the one thing that seems to be the interaction of the two communities between the commercial and the science is that this whole concept of non-interference, you know. So how close can you get to somebody on what somebody's doing on the moon without interfering, you know? Kelso did that stuff for the heritage sites, and they were saying that, you know, some of the exhaust plumes will send particles orbital. And so these are some of the things, you know, what is an exclusion zone? You know, a lot of people are trying to use the law of the sea, but what's a reasonable exclusion zone around what you're doing that somebody else should keep out? So, I mean, those are some questions that I think are going to affect both commerce and science.
Yeah.
Let's Aditya, who's been waiting. Then we'll have Margaret.
All right. So just to call all the science community's attention to the capabilities that the commercial landers and rovers have. We've put some of them on our poster. There was some more on the presentation yesterday. So is there any such capability that is useful for you to put into a proposal later on, and especially the rover, because rover is mobile and it's also constrained. So if the capability, like what I said before, which is if it's to survive the lunar noon closer to the equator, that means the mass goes up, the cost goes up, and the complexity of landing such a system goes up. So if it's easier to target and do more science in mid-latitudes, that can be done easier at a lower cost, and then we could work our way both closer to the poles and closer to the equator. So that could just tie into a roadmap for commercial guys to get in, because the cost increases if you go north or south.
Understood.
Yep.
Yeah, so there's another one which is I wanted to call attention to the Chinese, who are putting an Earth Moon L2 relay, I think, for their far side mission. Just wanted to state that the costs are using the relay as a service might become a need, and we can't ignore that fact. So we're telling that we can't do far side missions, but if China has a relay there, does the rest of the world just pay them for using that service? Because nobody else seems to be going and doing that.
The rest of the world except the U.S.
Right. We're forbidden from doing that. We in the U.S. are forbidden from doing that legally.
Yeah.
So that may change eventually, but for now, that's the case. However, there are other internationals here that may be able to take advantage of it.
Yeah, but because of that geopolitical thing, that there are many other countries also that may not be able to use the Chinese asset.
Right.
Right.
It's just that I'm just telling that we need really that relay, either as a national agency putting that up, or commercial folks like us putting that up.
Mm-hmm.
Right. And that's something I don't want to get too much into the next session, but the comm is definitely something that we realize from the far side. So thank you for bringing that up. Margaret?
Yes, I just wanted to follow up on the idea of, as we build an atlas of resources and a wish list for which sites you want to go to, following up on previous ideas, we have that information scientifically. Scientists want to go to particular spots because of the science that they can do. The commercial folks in partnership would like to land in certain places and know what are the guidelines that they may need to use. And then, is there some prospect of eventually doing something like zonation? I don't know. You mentioned, protection zones. Are there distances like what was done in Kelso's report, where he said that don't land within a certain amount of distance? But to the extent that the science community can put that together, that goes forward to COSPAR. And even at that point, it doesn't guarantee that it'll go on to become part of the guidelines and rules that are adopted internationally. But the more you give them that thinks forward to management, the more the science will be useful in addition to the science.
Thank you. Thanks.
This is why you get paid the big bucks, Margaret.
Carly?
I want to follow up on that directly, and I hope I'm not opening up a can of worms. But this particularly applies to polar science and to polar exploration. That we visited the South Pole. We have El Cross, and it had this marvelous science experiment. The more assets we send to the poles are going to have various plumes that will carry out across that relatively pristine area. Putting on the science hat, we don't know what's there. We don't know the character of the science. We don't know what these deposits contain. If we go to both poles for science and for exploration, we may never get that because we've contaminated them both. I think it's well worth considering that we focused, or at least recommend, I don't know if COSPAR can make a strong recommendation or what, that as we're going to the poles for polar science, we go to the South Pole and leave the North Pole, which clearly have the similar deposits, pristine until we know what to do, for science. We could easily destroy some of the principal science record if we're not careful.
Carly, that's a super good point, and that's of course related to the physical environment. Jack Burns had his talk on Cosmic Dawn earlier, and he's of course really concerned about contamination in the radio spectrum, 30 to 120 megahertz. So I think that the general point about doing one thing and having it impact another, we as a community need to think that through.
And Carly, when you said that the other day, that's precisely the kind of zonation and management, and it will go up because Chris McKay will take it to PEXT in COSPAR. And so if this group makes that one of the recommendations, it's not a restriction, it's not a law, but it is a guideline that makes a heck of a lot of sense. And if it's wrong later on, that's okay, you can change it. And you haven't affected any of the science or the uses later on. So make it if you want.
Okay, Jack.
I'm not a space lawyer. I don't play one on TV. But I just want everyone to remember that as a signatory to the Outer Space Treaty, any nation can set guidelines for its people, or with like-minded nations set a set of guidelines that they or it will say it will adhere to. And I think you have to remember that your recommendation can be for the United States to begin to consider as guidelines, and it can act unilaterally because it's a signatory to the treaty so long as it works within the parameters of that treaty. And there has been discussion of sovereignty. There is some sovereignty built into the treaty because if you have a facility on the moon or any celestial body, there's a provision for mutual visitation of those facilities. Mutual is the guidance. There has to, you're fine, you can protect your assets and everything like that, but you do have then to agree to allow mutual inspection of those facilities. Yes, and with notification. So it's a form of sovereignty that already exists within the context of the treaty. But again, any signatory to the treaty has very broad parameters under which it can operate with its citizens. You just have to remember that. It doesn't have to go through COSPAR. Having a recommendation for COSPAR, fine. I have a recommendation from anybody is fine. But COSPAR, as long as the treaty is the only really operative space law that we have, then it's merely a recommendation.
Thanks. Jeff? Yes.
Okay, so I'm going to try not to monologue, but on the topic of regulation, one of the things that scares the people that have the big checkbooks is when we start talking about regulation. So if there's uncertainty, then they don't want to help us be able to fund us to be able to get you guys to the moon with that uncertainty, the wait and wait and wait, which means that we wait, which means that you wait. So if we're going to talk regulation, we really need to think smart about it and keep it simple and small. And if there's places that we don't want to go, say, don't go there, we're going to go over here right now. But that could also limit the science that you're doing because we're putting places that you want to go off limits. So we need to be really smart about the regulation and keep it as simple as possible, I think. So that's it for regulation. I think more to Clive, what you had said, on the commercial standpoint, I think the takeaway everyone here should have is, remember, we're developing things and we're building things. So if there's stuff that you didn't see in our presentations that you want, or there's capabilities that you're wondering that we have, or things that we can do, engage us, talk to us, because we're willing to help you, we want to help you. You're going to be the ones that drive us getting there. So you're the reason, you're the payloads that we want to carry. If there's something you didn't see, if you looked at our lander and said, oh, my payload's not going to fit on there, come talk to me, come talk to Dan, talk to us. We can accommodate, within reason, we can accommodate things. So engage us so that we know what you want. This has been really helpful because now I know where you want to go, but I don't necessarily have an idea exactly what you want to do there. So talk to us. Okay, we're here, we're available, and the more data that we get from you on what you want to do and what payload you want to carry there, the more data we can get back for you.
I would like to say right now we have an annual Exploration Science Forum that Survey runs. I would be keenly interested in having a commercial lunar session at that. And the league meeting, that's right, league meeting, the CAB always meets there. So I think that's kind of a fixture now at the league meeting. It hasn't been at the forum, and I would really like that to happen. Okay. So and this is a message to everyone here from the commercial sector.
Okay, sounds good.
Great. And it's going to be announced next week, I believe, Brad, is that right? Yeah, next week. Okay. So.
Pete Humphreys, AMS Inc., San Jose and UK. So with the habitation modules and the scientific modules, you need to drive down the cost by economies of scale. They need to be flexible and reconfigurable and upgradable, and you can make many more. Doesn't matter if it's going in low Earth orbit or on the surface of here or in situ on other planets or Mars. Drive down the cost by making them flexible and reconfigurable. That's one. Two, from a perspective from an engineer, you can make tracked vehicles lightweight, and they have more stability and more traction. Three, get the movie industry involved so we get good publicity. Okay? Otherwise, we're all preaching the choir here. You've got to get the public on our side. Thank you.
Great. Thanks, Pete. Mark.
Yes. First, responding to Margaret's comments about not messing up the environment on the moon and managing the environment. There are other communities that need to be incorporated into that. First of all, the ISRU people who want to dig up the surface, and the people who want to go after helium-3 and dig up a 100-meter square area, a meter deep, to get 5 grams of helium-3, And then there's the science from the moon community, not just the Far Side Radio Telescope, but also observation of the Earth from the moon. And there's a small cult of far infrared astronomers who have a target that's above the North Pole they want to see. And so there are all these different, these different constituencies that have to be corralled to consider environmental management. And then to go in another direction, there needs to be a much stronger connection between each of the scientific communities and the human spaceflight, human exploration community. Because my experience in observing space station and having worked on ISS from the early 80s, the basic objective of Mission Operations Directorate was to keep science out of the space station. And partly we were responsible for that. I worked on the first Space Lab Life Science mission from Ames, where the rat turds floated out in the edge vortices from the rat cage. And that gave us a terrible reputation in that respect. But also, basically they just didn't want to deal with the complexity and the potentials for contamination. And as Dave Morrison put it, scientists complain a lot more than engineers. So this is something to be careful about. I mean, and partly the science community, if they want human exploration to support science as opposed to excluding it, needs to start attending human spaceflight meetings and conferences and advocating in those forums.
Mm-hmm.
Mm-hmm. You can't expect that if once in a while JSC sends a token HEOMD guy here, that's going to make the connection.
Yeah, we have a number of people from human spaceflight here. I'm looking at one right there, Victoria Friedenson. Ben Bussey is around. There he is, and back there. Both of them are from headquarters. There's a number from the community, and so this is something that is something we agree with very much. So anyway, Tim, you have the last question in this session.
Yeah, just very quickly. Following up on the last couple comments about kind of communicating the results of this this meeting and making sure we kind of hit all the relevant stakeholders. Yeah. I wonder if there'd be support in this room for putting together a journal special issue. A lot of people have done a lot of work on characterizing their sites, on putting their missions together, mission concepts together. We're kind of 2 weeks away from the deadline for submission for the survey special issue. If you got an idea, you can submit to that as well for JGR. But putting together a session proposal or a special issue collection proposal is pretty painless. If there were a dozen or 2 dozen people that could have a paper on their favorite site or their favorite mission put together in 4 to 6 months, then I think it'd be something that'd be really useful, and it would gather all of the concepts kind of in one digital space that our commercial partners or HEO people could access and see everything all together really easily.
Well,
I like that.
It would also allow people who aren't here to become involved in the process and open up a lot more. So yeah, I think that's a good idea. I'm going to put everybody on the spot. Who here would be interested in participating in such a special issue?
Yeah.
There's more than a couple right there, and I think if we get that out over the Lunar L, we'd have a few more.
Yeah, so I can follow up with you on that. I'd be happy to organize that.
Let's do that.
That's great. Thanks, Tim. That's a great idea. Okay, so this session is now closed, and I want to invite up our note takers.